Alright, so in this video we'll be talking about logic gates. Logic gates. So our learning objective will be understanding the role of logic gates in computer system, and then identifying the common logic gate, talking about the AND, the OR, the NOT, and so on. Then we'll be looking at the interpretation of the truth table of the logic gate and logic circuit. The first one on the list is Boolean logic. The brain of any computer is in the CPU, the central processing unit. The CPU fetch information from the main memory and execute them. And the ALU, that is the arithmetic logic unit. The arithmetic logic unit is the component within the CPU where logic decisions are made. This decision making process is called Boolean logic. That is, the decision that the CPU will be making is called the Boolean logic. Boolean logic. As you can see here in our logic gate, the Boolean logic is represented using logic gate symbol. The logic gates are the fundamental components of digital circuits. They perform basic logic functions that are essential for digital computing. Let's explore the most common type of logic gates. So the first on our list is AND gate. AND gate. An AND gate output is high, and so the first on our list is AND gate. An AND gate output a high signal. An AND gate output a high signal, that is 1 or on, only if all its inputs are high. That is, the output will be on when all the input is on. Here is a truth table. Let's say example of a truth table. So as you can see in this table, we have the input and the output. The output is 1, that is, the output is high or is on only when both inputs A and B are on. That is, AND gate has 2 inputs and 1 output. So the A and B, you can see when it is 0 0 in A and B, it is 0. When it is 0 and 1, it is 0. When it's 1 and 0, it is 0. So it is high, that is, it is 1 or it is on if both the input is on. So that is it. The next on our list is the OR gate, that is OR. That is the symbol there. This one also has 2 inputs. So as you can see, an OR gate output a high signal, that is 1 or on, if at least one of the inputs is high. That is, in AND gate is when both the input is high, but this one, if any one of the input is high, the output will be high. So let's check the truth table. The output is 1 if either A or B is 1. So you can see in the truth table, when both are 0, the output, that is the Q, is 0. When either A or B is 1, both are the output will be 1. And when the both is 1, the output will be 1 also. So the next is the NOT gate. The NOT gate. The NOT gate, or the inverter, they also call it the inverter, is the simplest of all logic gates. It only has one input, that is 1 input, 1 output, while the OR and the AND has 2 inputs. It has only 1 input where the input is the opposite of the output. That is, if the input is 1, the output will be 0. So let's check the truth table. So you see, we have the truth table. When A is 0, Q is 1. When A is 1, Q is 0. So just the opposite. So we have the SOR gate. So the simplest OR gate is a 2-input digital circuit that outputs a logical 1, that is a high signal, if the two input value differ, that is its output is a logical one if either its input are 1 but not at the same time. So you can see the truth table here. We have two inputs, A and B, and Q is the output. So if A and B is 0, the output will be 0. But if either one of the A or B is 1, or they are high or they are on, the output will be on. But if both A and B are on, that is they are 1 or they are high, the output will be 0. But if you compare this, it's not the same thing as the OR gate. The OR, even when A and B are 1 or they are high, the output is still 1. But the OR, if both are 1, the output will be 0. Then next on our list is the logic cycle. So this is when they combine two logic gates together. Multiple logic gates can be combined to create a logic circuit. In this example, the output of the OR gate is reversed through the NOT gate. That is, there are two logic gates here. We have the OR and the NOT. So the OR has two inputs, while the NOT has only one input. So you can see here A and B. When A and B is 0, the output, which is the Q, will be 1. So looking at this, in the OR gate, if one of the input is 1, the output will be 1. And when both is 1, the output will still be 1. So, and the NOT gate is the reverse of the input. So if you can see here, the A and B is the input. So when A is 0, B is 0, the output is 1. So yes, the output is 1. The reason is that when A and B are 0 in OR gate, the output will be 0. And in NOT gate, the output is the reverse or the opposite of the input. So when this side, the input of the NOT gate is 0, the output will be 1. Then the second one, the second line, the second row, when A is equal to 0, B is equal to 1, the output of the OR gate will be 1, and the NOT gate is the opposite of the input, so it will be 0. Same tutu there, so you can follow it. The third row, when A is 1, B is equal to 0, same thing there. So we have this gate. So I would like you to take a look at this gate, analyze it. If you understand it, let me know. If you don't, let me know in the comment or make a video about it. It's very simple. Thanks for watching, and make sure to subscribe.